Dr. Daniel Siegel is a pioneer in the field of interpersonal neurobiology and the clinical application of mindsight. Despite authoring the foundational texts on emotional regulation, Siegel experienced an aggressive behavioral meltdown when his children started arguing over a crepe. This episode was a physiological event known as a lid flip. A lid flip occurs when the brain's higher reasoning center shuts down, leaving primitive survival mechanisms in charge of behavior. This image shows the prefrontal cortex, the hardware regulating survival mechanisms. Sitting behind your forehead, its middle section is the integration hub, exactly one synapse away from the higher cortex, emotional limbic area, and primitive brainstem. In Siegel's hand model, the wrist is the brainstem, the tucked thumb is the limbic system evaluating threats, and the folded fingers are the prefrontal cortex. During a lid flip, the prefrontal fingers flip up and disconnect, leaving the reactive limbic system exposed and dominant. This physical architecture dictates what is called the triangle of well-being. The mind, the brain, and our relationships operate together as a single, interdependent functional system. Relational capacity relies on an intact, integrated nervous system. When the prefrontal cortex disconnects, the neurological substrate required for connection is physically suspended. While the children's argument over a crepe triggered the event, the conflict served as a bridge to a deeper neurological stimulus. This stimulus is known as an implicit memory, a past relational experience stored below conscious awareness that actively shapes current physical reactions. During a limbic hijack, an incoming sensory signal bypasses the prefrontal cortex and shoots straight down into the ancient, reactive centers of the brain. This flowchart compares two brain pathways. The high road routes signals up for integrative processing, while the low road goes straight to the limbic system. When active, the high road goes dark, bypassing prefrontal processing. This ancient superhighway instantly activates survival responses before thought intervenes. In Siegel's case, seeing his daughter and son argue caused his nervous system to map them onto a painful sibling dynamic he experienced 40 years earlier. This image shows how early emotional threats are studied in children. These developmental experiences physically hardwire the nervous system, creating pathways that remain accessible in adults. Siegel's nervous system was responding to an unresolved threat from his own past, rendering him blind to the present moment reality of his children. The human brain cannot sustain intimacy mode while locked in survival mode. When a partner is categorized as a threat, the social engagement system shuts down. The middle prefrontal cortex operates as the hardware running 9 distinct relational software programs. This dashboard illustrates 9 interconnected prefrontal nodes, regulating everything from the physical body to morality. When the limbic system takes over, the prefrontal power source disconnects. Bodily regulation, attuned communication, empathy, emotional balance, response flexibility, fear modulation, insight, moral awareness, and intuition all collapse simultaneously. These deficits are offline neurological functions. They are not character flaws or voluntary communication choices. When the insight node is disabled, individuals fall into the insight trap. They cannot recognize their own dysregulation because the brain region required to observe themselves has lost power. Cognitive reasoning cannot force these 9 functions back online. You cannot think your way out of a low-road activation. To recover, Siegel used physical movement. He took a skating break with his daughter, using somatic sensory input to settle his nervous system. This intervention relies on the brain extending into the body. Because visceral neural networks send data upward, physical signals can be used to interrupt limbic dominance. This diagram demonstrates biological recovery. Somatic regulation sends safety data upward through a steady pulse, jump-starting the prefrontal cortex. Once online, it fires a downward arrow labeled the GABA inhibitory pathway. This neurotransmitter executes a cortical override, suppressing the fear center and calming neural activity. Genuine reflection is impossible while the fear center is active. The body must cool down before the mind can follow. This diagram shows the tripod of reflection, the mental structure required to successfully repair a relationship. The 3 legs click into place. Openness accepts what is present. Observation perceives yourself during the experience. Objectivity recognizes that temporary thoughts and feelings are not your identity. Without a stabilized tripod, the internal lens is too shaky to see the situation clearly. Self-awareness becomes physically inaccessible. Attempting a relational repair with a flipped lid is neurologically ineffective because the necessary prefrontal circuitry is offline. This flowchart compares two approaches to conflict. Path A attempts to relate while dysregulated, deepening the rupture. Path B regulates the body, reflects internally, and then reconnects. Path A fails because the partner's nervous system detects the absence of empathy. It registers emotional withdrawal as an active survival threat. Path B succeeds because it follows the brain's requirements. Regulating the body first is the necessary first step for restoring relational connection. Early experiences alter the regulation of our genes through epigenesis. This shapes how our nervous system responds to stress, but it is not a permanent destiny. Practicing regulation repeatedly creates physical changes in the brain. As these neural branches bind together, they forge entirely new biological pathways. Focused attention during somatic practices stimulates neurochemical release, which alters gene expression and constructs new synaptic connections. You update subcortical trauma by repeatedly having a different physiological experience. Experiencing a state of safety in relationship trains the nervous system to expect it.